Before we get too far ahead of ourselves in adding components to these schematics, I do want to finish off the last bit of the basic package unit or residential unit. Okay, in most parts of the country, even if we don't use it, like in the South, we don't use it that often, we must have heat in every occupied building. You must have the ability to heat the building on cool days. Okay, in the Northeast, northern part of the country, Midwest, in the cooler climates, it's mostly going to be either gas heat or oil heat. The further to the southern climates you go, it's going to be electric heat or heat pumps. But we're going to leave the heat pumps off the table for now. We'll get back to that. But we need to talk about how we're going to add a heating circuit to this. Now, for the purpose of this video, I'm going to toss in an electric heat element. And I'm going to identify where in the video you would actually do or where in the schematic you would do your connection to, for example, a gas furnace, okay? But in this case, we're going to put in we are actually going to put in an electric heat element. Okay, so this is the same schematic we left off in the last video. We have a basic cooling circuit. We've put in our indoor fan. We've put in our cooling side of things. We have our compressor. We have a condenser fan, indoor fan motor, indoor fan relay, compressor contactor, or cooling contactor, depending on how you want to look at it. I've made a copy of this diagram to start with, okay, and that's where we're going to start. Now, we're going to use the same thermostat because, again, we have a W terminal here. Okay, so our W terminal is in case of heating. Okay, our temperature drops and closes the connection between R and W, providing 24 volts or actually 26 volts on the output of the W. Okay, so let me go back over here to our schematic symbols, and we're going to start off with the basic schematic symbol for a heater. Okay, let me copy this, and I'm going to come over here, and our electric heat is always going to be on the line voltage side of a system. Okay, and I'm just going to, again, I'm going to put this in here. Okay, now, with electric heat, there's something that's absolutely required. You must have, and this is, you absolutely must have a high limit switch. Okay, in case this heat starts up and doesn't shut off, this is a heating element. It can cause a fire. So what we have to do is someplace between our line and our load, which is the heater, we have to put in a high limit switch. Now, a high limit switch is just a normally closed, open on rise thermostat. So we're going to come over here and we're going to put our high limit switch in. Okay, and again, it's just a normally closed, open on rise thermostat. I just want to put this someplace where it's not gonna, oops, that isn't what I wanted to grab. Okay, so we have our high limit switch. Okay, now I can connect this in to the heater, and sorry about the little line there, I'll fix that in a few minutes here. Okay, so we'll connect that in. Now I can come in and I can grab the same normally open relay or contactor, and I'll paste that in here. And notice my schematic's getting tighter, so I got to start really watching my space available, okay, because we're starting to get tighter on things. And so put that over there. Okay, I'm going to do the same thing for the other side. Copy that, paste that. Okay, now I got to do some labeling before we go too much further. Okay, so let me label. This is going to be heat relay. This is going to be HLS for high limit switch. This is going to be heater, or just HTR. And this is going to be, again, heat relay. Okay, so now that line's in there. So when HR closes, as long as the high limit switch is closed, which means it's safe to operate, we're going to energize our heater. So now let's talk about down here at the bottom, how we're going to handle the control voltage side of this, because there's a couple pretty important things. Okay, so we are going to come out of our W terminal, okay, and we're basically going to use the same idea we used here, okay? All we're going to do is come out of W and control a coil. Oops, that wasn't the one I wanted. Let me recopy that. Sometimes it's nice to have the electronic stuff because I don't have to always. So we're just going to call this, I'm going to get rid of that C1 there because I don't need it. And this is HR. Okay, then I do need to come out here and extend that down. So now I have a heat relay that is calling when the thermostat temperature drops and is calling for heat. Now there's more that's going on in this thermostat right now, and we're going to talk about this probably in our next video when we talk about air proving switches. Okay, but before I can energize this HR, I have to make sure my indoor fan motor is running. Okay, if my indoor fan motor is not running, I cannot energize HR. And we have a couple different ways we can do this. But one of them is going to be an air proving switch, and we can also look for the amperage on that indoor fan motor. I much prefer the air proving switch. So that is how we deal with the heat relay and the electronic heat element. Now the HLS, the high limit switch here, is here for a very simple reason. If for some reason airflow is blocked, or if HR fails in the closed position for some reason, we do not want this heater to stay energized. It's going to heat up to a certain degree, usually about 180 degrees, and after it reaches 180 degrees, it's going to shut off. That's how we deal with our heat relays and our electric heat. Now, remember, I said most often electric heat is used in cooler climates or where space is limited or there's no natural gas or oil. Okay? But HR could also be a relay that controls a gas furnace. Okay? So HR could be a relay on a furnace, on a boiler, or something else. All it is a heat relay. It doesn't necessarily have to control an electric heater. We're going to talk about that more as we go further in the schematics. So this is a package unit that you might find in the southern climates or any place where electric heat is required. Again, all I'm missing here is that air proving switch, and we'll add that in another circuit.